Welcome friends, and in this video I am going to discuss about two very important examples and compare their acidities, right? So you can see these are the two molecules. They look similar, but the only difference is that in this molecule the chlorine atoms are this side, and in this molecule the chlorine atoms are right hand side. So you can see the carboxylic acid group is far apart from these chlorine atoms, and their positions are same. So chemical the nearest chemical environment of this carboxylic acid groups are same, and so you would expect the same acidity, that is the same pK value for these compounds. But you can see the pK value for molecule A is 6.07 and that of molecule B is 5.67. That means molecule B is more acidic than molecule A. Now why is the difference? So this question once asked in your JAM exam, and it is also important for any competitive exam like NET or GATE. So why is the difference? Now whenever you compare the acidity of two compounds, you have to compare their, so you can compare their initial structure, but the best is you should compare the stability of the corresponding conjugate bases. That means after acid dissociation you get this conjugate base from molecule A and this conjugate base from molecule B. So now you have to compare the stability of these two. So you can see in this case the chlorine atoms are at the same side of the carboxylic acid group, although they are far apart from each other and there is no direct interaction between them, but still there will be influence. So you know about two effects in stability of the reactive intermediates. That is, number one is inductive effect, which is through the sigma bond. That is, the halogens are minus I effect showing, and the methyl groups, OMe methyl groups or other groups which are plus I effect, that is they push electron. And another type of effect is minus R effect or plus R effect, that is through resonance. But all these effects, plus R, minus R or plus I, minus I, they are through the bond effect, either through pi bond or through sigma bond. But in this case this effect is not through bond, but it is through space. That is, you can see due to the presence of this negative charge on this carboxylate anion, and also there will be lone pairs on this chlorine atoms. Okay, so they both are negatively polarized, and that's why in this particular case there will be a Coulombic repulsion between these two groups. But you can see in this case these chlorine atoms are far apart from the carboxylate ions, and that's why there is no such Coulombic repulsions, and this makes this conjugate base less stable than this, and that's why its acidity is lower. That means this is reluctant to undergoing dissociation. So this type of effect is called field effect, and it is not through bond but through space. So this is a very important concept, and this example is only given in the book of Csir-Net. So although in the video where I suggest you books for organic chemistry, I didn't mention about Csir-Net because the book is not, you don't need that book to read full, right? Because the book is very bulky and not all the things are so important. You can read other good books like Claydon, but some examples are given in that book which is not found in any other book. So you should read all the books, right? So there are many books in the market. You should at least once read the books. You can read one chapter or something you need for that moment, but you don't need to read through all the books thoroughly, right? So there are some examples which are found in a particular book that is not found in other books. So you have to look into the book. So to learn organic chemistry, to gain concept, you have to always read books. There is no other source than book which is good for particular subject, right? So this is one example, and another good example of this same kind of effect is this molecule. So let's say you have this molecule where you have a carbonyl group here, two methyl groups are there. Now you know, norm, this is a CH2 group, and here you have another hydrogen. So if you compare the acidity of the molecule, first of all, this hydrogen will not be acidic. Why? Because in this case, if it is so, this is adjacent to carbonyl group, but you know, the carbonyl group stabilize the adjacent anions through the resonance, right? So let's say you have a molecule of acetone. It is, these alpha hydrogens are acidic because the negative charge developed here can be stabilized through this resonance, right? But in this case, this hydrogen is not acidic because if you draw the same type of enolate here, that is impossible because this is a bridgehead position, and in bridgehead position you cannot get a double bond. And you can see here there is no alpha hydrogen, so only possibility is these beta hydrogens. So are these beta hydrogen acidic? Yes, the answer is yes, because it is not that much acidic, but it is more acidic than normal CH2 group. So you have, if you take a normal saturated CH2 center, that will not be acidic, but this molecule, if you treat with base like tert butoxide, it can show acidity to give you this anion. Now if you think about the inductive effect of this oxygen, so inductive effect is not that much at that point. It is only prominent at this alpha center. Beta center, the inductive effect is very less. So but why this is forming? So this is an extreme case of field effect, and you can replace this and particular anion you can write like this. So as you can see, although this is far apart from this carbonyl group, still this negative charge can be stabilized into this carbonyl group, and that's why this conjugate base is stable, and this is the reason that these beta hydrogens are acidic. So these two examples are given in the Csir-Net's book, and they are very important examples because in exams you can be given question from this topic, and if you don't know you cannot answer because this is a little bit different topic. So I hope you will enjoy this video, and if you like it then give thumbs up and also share this video with your friends, and thank you for watching.